have struggled with that in the past? Right, so division 3, number 2. Okay, guys, thank you. These questions where they give you an expression, then they tell you what the value of each variable is, and then they ask you to do calculations. I know in your first algebra test this year, it didn't go well with those questions, and then I think in the June exam also, a number of you struggled with those. So guys, what you need to do is, for A, for example, right, you need to actually understand what the expression is saying. Because if you don't understand that, you're going to do the wrong calculation. So if it's an A and a B and a C and a D, what are we doing with those values, guys? Those variables at first. We're multiplying. Okay, so the next step, or actually your first step, I suppose, first step kind of is figure out what's going on in the expression. Next step is going to then take the values that they've given you, right? They tell you A is 2, B is -3, C is 5, and D is 0. You're going to write those values in your expression. Guys, you could have used the dots again, or you could have used the times symbol. All right, either or any of those three would be fine. I put brackets around them because there's a negative. Okay, so I'm always a bit nervous that if there aren't brackets, that you guys forget that negative. But if you wrote 2 and then a -3 and then a 5 and then a 0 like that, that would be fine. Just remember that there is a negative. In this case, it really matters because what is anything multiplied by 0? 0. Alright, so it doesn't matter what the first 3 numbers are, because you're multiplying that whole thing by 0, your answer is going to be 0. This would be a 2-mark question, guys. One for showing that you put the values in, and then one for the answer. Alright, for B, what are we doing? I'm subtracting B from C. Right? Do we understand that? C minus B. So I have to take my C value, which they told me is 5, and then I have to minus the B value from it. So guys, the B value was -3. So you're minusing -3. Right? What happens when you have a minus and a minus next to each other like that? It's a plus, right? So you're actually the same 5 plus 3, which is 8. Okay, the next one was a fraction. So I'm just going to move across. They said a cubed over b squared. So you take the value of a that they gave us, which was 2 cubed. And then b was -3. So we need to square -3. Right? It's a good idea, guys, to put those in brackets. With these types of questions, I always put my values in brackets. Sometimes it's not necessary, but often it is. So it's a good idea to just do that always. 2 cubed is 2 times 2 times 2, hey? We notice that's 8. So I'm fine with that. And then what's -3 times -3? +9. Okay, so that answer is 8/9, which you can just leave like that. You can't simplify that. If it was 8/10, would you be able to leave it like that? No, then you would have to simplify it to 4/5. Okay, so just always check, guys. In any question, any topic, if you're getting a fraction, you always have to simplify it if you can. All right. For D, the next one, they're now asking us for, and this is a bit more complicated, in brackets AB squared. So A times B squared. Right? So we're all fine with that, if that's what that means. But then that whole answer needs to be raised to the power of D. So guys, for this one, again, because I had a negative, right? Because the B value was a negative, I used 2 sets of brackets. Okay, but it also would have been fine if you did it like this. If you say 2 times -3 squared, but then you must remember to close that bracket. Okay, so just be careful. Usually when I can tell that I'm going to have 2 sets of brackets, I use square brackets for the first one. But it doesn't matter, this is also fine. But if you wrote it like this, guys, 2 and then a -3 and then a squared, and then you didn't close that bracket, that's going to be wrong, right? Because where are you going to put that other exponent? Okay, so just be careful there with your brackets. So guys, this was another question almost like A, where it doesn't really matter what you have on the inside of this bracket. Because what did we say yesterday? What is anything to the power of 0? No. 1. You didn't actually even have to work this out. You could have, right? This would have been 18 in the bracket. Okay, so it's fine if you did an in-between step. If you said, we all agree, negative 3 squared is 9, right? And 2 times 9 is 18. So you could have said this is actually 18 to the power of 0, which is then 1. But guys, you're not going to get a mark for this thing. Okay. We do expect you to see, oh, okay, it's a big bracket, but it's to the power of 0, so it's Alright, so all of these questions actually, guys, are worth 2 marks. It's a mark for the substitution of showing the values, and then a mark for the answer. Alright, those of you that struggle with these types of questions before, do you feel okay with just, giving you the values and put them in and work it out? Alright, number 3 was a bit of a problem-solving question. So they said Maria was asked to find the cube root of a large number. We factorized it into 5 factors, and we got 2 to the power 3 times 3 to the power 6 times 5 to the power of a hash. So it's great, and Marty saw that she had smudged the final index, which is exponent, right? Index is exponent. What possible values can the hash stand for if the number had a natural cube root? Oh, and sorry, I didn't actually see that last bit. And the hash is a single digit number. All right. So first, I'm going to add something to it now, when you actually can. Do we all agree that, well, let me rather say this. Remember yesterday, I'm going to go back to an example that we did yesterday. Where was that? This one here, right? Where we said the number outside of a square root is a 2. Do you guys remember that? So to get the square root, if we have exponents, we divide those exponents by 2. Now, if we have a cube root, guys, what is the number on the outside there? A 3. So in order to get a whole number, because if we're saying a natural number, that's a whole number, right? In order to get a whole number, all of these values that we have, all of these exponents, we need to be able to divide them all by 3. Okay, if you have, for example, the cube root of 2 to the 6. Right? What are you going to do with that? What did we do up here? We said exponent divided by 2, because they were asking for square root. If we have to do cube root, we're going to say exponent divided by 3. Right? So this would be 2 squared, which is 4. But now what if I get this, guys? The cube root of 2 to the 7. Now I would have to say, okay, 2, and then I'm going to take that exponent divided by 3. But is that going to give me a whole number? Right? 2 to the power of 7 over 3. Right? We don't even know how to work that out. You can work it out on the calculator. I'll show you quickly just what the value actually is equal to. It's that. 5,0396842. Okay, that's not a whole number. So guys, in order for you to get a whole number, a natural number, as the answer to a cube root, the exponents have to be divisible by 3, or like what I wrote, a multiple of 3. Right? Does that make sense? Otherwise, you're going to get a fraction for your exponent, and that's not going to work. Okay, so let's quickly go back to this, because I didn't read that last bit of it. Okay, so the hash has to be any multiple of 3, or you can write, if you prefer, divisible by 3. That's also fine. If something is a multiple of 3, then it is divisible by 3. Okay, that might be good. You might understand that a bit better. Just hang on. But then they actually said in this last section, guys, and this is what I missed, that hash is a single digit number. So can I have 15? No, 15 is divisible by 3, right? But it's not single digit. So now we need to actually list all the multiples of 3 that are single digit numbers. So what do we think? 3, 6, and 9. Okay. Cool. Because I know that if I'm taking the cube root, I'm going to have to divide the exponent by 3. Okay, the only way for me to be able to divide the exponent by 3 is 4. So that is they ask for the fourth root. What would you think? What would the exponent have to be for you to have a whole number fourth root? A multiple of 4 or divisible by 4. Okay. That is the key. All right, let's look at division 4. I said you can leave out number 1 because that was a number type expression. So for 2, they wanted you to add this bracket to these 3 terms. All right, so you put those 3 terms and then you add the bracket that they told you to add. In this case, it actually would have been fine if you swapped the 2 brackets around, right? Because when you're adding, you can add numbers in any order. It doesn't matter. So you can just check for that final answer there, guys. You have to look for your like terms, right? So 2x squared minus 3x squared. That's negative x squared, right? And negative 8x plus 5x. Do we agree that that's negative 3x? And then if we're looking at our just numbers, constant terms, negative 7 plus 7, what's that? 0. Right, so that's why we don't have a number in our answer. The minus and cancel the bracket. The minus then cancel that bracket, so we have to multiply all of the terms inside the bracket by negative 1. That's for the next one. This is how we order is very important. They're saying subtract this from this. When you are subtracting, order matters, right? What's 5 minus 2? 3. What's 2 minus 5? Negative 3. So it's not the same as the swap them around. So you have to read very carefully, guys. We're saying subtract this from 2x squared minus 8x minus 7. So you have to write 2x squared minus 8x minus 7 first. And now you are subtracting a whole bracket. So you need to keep it in brackets, guys. Remember when you're subtracting more than one term, you have to always put those terms in brackets. Otherwise, you're going to get it wrong. Okay, I'm respecting that. And really would have made that mistake. The minor thing, the whole bracket, you must keep it in brackets. What number is in front of this bracket? A negative 1, actually, hey? Sorry, it kind of looks like my arrows are going from the 7. What? Because does that 7 have anything to do with the bracket, guys? The 7. No, it's a separate term, right? The number that I'm multiplying into the bracket is negative 1. Now, what is a negative times a negative? Positive. That's why that was negative 3x squared is now plus 3x squared. A negative times a positive is a negative. Again, a negative times a positive is a negative. Right, now that we've gotten rid of the brackets, now you can start looking at like terms. 2x squared plus 3x squared is 5x squared. Negative 8x minus 5x is negative 13x. Now, and negative 7 minus 7 is negative 14. Because we're just multiplying in the negative times the positive. Okay, any other questions on that? So that maybe we should write a little note because it looks like this was a common mistake. When you are subtracting multiple terms, when subtracting multiple terms, put those terms in brackets and multiply each term by -1. Okay. Any questions on that one, right? All right, for the next one, sorry, I didn't notice that they were asking you about types of numbers. That's actually not, I don't think we're going to be based on that. We didn't do that, okay? Let me just double check that scope quickly. You guys did get a scope, right? Because we do need to know something like what is a whole number, but that's almost like common sense. And when it comes to like rational numbers and integers, that wasn't actually in, yeah, we didn't do that. Where is the scope? Did you guys get a scope? Where can you remember where it's saved? Yeah, but is it? Oh, okay. I see. Um, yeah. So it's under the stream. You just have to scroll down a little bit. Okay. So there's the revision paper and a memo, and then there's some study tips, and then there's something about maths competitions here, and then there is the scope. All right. So that's all the stuff that you need to go through. So y'all guys, numbers, integers, and fractions, that's just basically like for numbers, it's basically working with bond mass. Integers, we did do that, but that was working with negative numbers, right? And then fractions is obviously being able to work with fractions. So don't stress about number 3, all right? We're not going to ask you to classify numbers like that. All right, revision 5, I want us to look at because it's quite a nice kind of exam question where they give you a statement and they ask you, is it true or false? Now, guys, in the next time they just said you must just say, is it true or false? I want us now to actually add, if it's false, what should it be? Okay, because that's what they do in case. They'll never just ask you, say true or false. They'll say, if it's false, you must correct the statement. Okay, so now for the first one, guys, for A, they've said x to the 4 times x to the 2. They've said that it's x to the 8. So they've multiplied those exponents together. Is that correct? No, what did you do? You're supposed to add them. Okay. So it is false, but please just add x to the 4 times x squared is x to the power of 6. Right, that's what it should actually have been. The next one, they're asking you 3x cubed squared. What's 3 squared? 9, hey? And then what do you have to do with those exponents now? Inside and outside a bracket, you times it. Okay, so 3 times 2 is 6. So that one is true. Let's go see what is anything divided by itself. 1, not 0. Hey, because 3x minus 3x, that would be 0. But 3x divided by 3x is just 1. All right, if we're looking at D, do we notice that these are actually not like terms? Okay, x, y, and x. They added them together. That's wrong. You can't do that, right? What am I meant to do? If I get a question like this, what did I just write? The same thing again, hey? So xy plus x is just going to be equal to xy plus x. Okay, you can't add those two together. So you would just have to rewrite the future. Okay, now E is a tricky one and it's also a common mistake, right? So if they're asking a question like this, they will probably ask something where they try and trick you here. Guys, where do you have more X's at the top or the bottom? At the bottom. So can I be left with X's at the top if I have more at the bottom to start off with? No. So guys, if you actually work this out, X squared over X to the 4, you're saying we have more X's at the bottom, right? How many more? 2. So you're going to have an X squared at the bottom. But now what does I put at the top? A 1. Because what are you actually doing? You're dividing, right? And when you divide and you cancel everything out, there's a 1. What is negative 3 plus 7? They've got negative 3 minus 7, you see, to get to negative 10. They're actually asking negative 3 plus 7. What's that? 4. Negative 3 plus 7 is actually equal to 4. Negative 3 minus 7 is negative 3. Alright, guys, we agree that G is actually correct. If you have 8, I mean, what's a plus and a minus? What happens there? What's the positive times the negative? Negative, right? So this is actually a minus. So now you have 8, and now you subtract 9. That's negative. No, you have positive 8, and now you subtract 9. So we're going to negative 1, hey? 8 minus 8 is going to get you to 0, but then you must minus another 1. So you're minus 8. Okay, so that one was true. The next one was also true. Negative 2 plus 2 is 0. Right? We've done a few in the algebra questions where that happens, right? The next one is also true, guys. This is negative 6 and then minus 5. So you're starting at negative 6, see if you can visualize that number line. Then you're going another 5 spaces backwards into the negatives, right? So that is going to get you to negative 11. And now what's happening here? What did they do to get to negative x cubed? They actually times them, hey? You see that? If you have negative x times negative x times negative x, that's going to give you negative x cubed. We are meant to be adding them, guys. So I'm actually going to write it here underneath. If you have negative x plus negative x plus negative x, what is a positive times a negative? Negative. And again, what's a positive times a negative? Negative. So that is equal to negative 3x. And that's why that one is false. You need to be adding and not multiplying. Okay, that was 5, hey? Yes. Were there any other questions in revision 6 that you wanted me to work through quickly? Just look through your working and see when you're struggling with any of those, the first one. Okay. Right, so for revision 6A, that was the revision question. Right, let's take a look. 12 divided by 8 is that going to be a whole number? No, hey, but I can simplify. What number goes into both 12 and 8? 4, okay. So 4 goes into 12 3 times, and how many times into 8? Twice, 2 times. Okay, so in my answer, guys, I'm going to have a 3 at the top and a 2 at the bottom. Okay, let's see what else we're going to have. X's, where do I have more X's? At the top, how many more? 5. Okay, so I know I'm going to have a 3 and an X to the 5 so far. I do know that I need to have a 2 at the bottom, but let's just check for the Y's. Where do I have more Y's? At the top, how many more? 4, hey? That's 5 there and 1 here. So we end up with that over 2. Okay. So guys, usually they give like 2 marks for the numerator. There will be a mark for the 3 and then a mark for these 2 things, and then 1 mark for the denominator. Okay, so that should be it all the 3 marks. Yes? Did anyone want me to do B? I think I can. It's not going to take that long. Let me just do it. All right, what is 5 times 7? 35. Now we're multiplying, hey? We have 6 x's and another 1x. What's that? How many x's are there altogether? So x to the 7. Remember when you times, we add those exponents together. Now we have a y to the 1 and a y to the 9. So that is going to give me y to the 10. Right, let's look at C. Now we have to arrange everything in the bracket to the power of 4. Okay, 2 to the power of 4. Do we know what that is? 2 times 2 times 2 times 2. 16. Good. So 2 to the power of 4 is 16. And now I need to multiply those exponents together. 16, hey? So x to the power of 16 as well. Alright, so let me quickly move D across and we'll do D as well. Okay, D is an addition and subtraction question, right? So what I want us to do first is to just sort out what's happening here. What's a plus, a positive times a negative? Negative, hey. So that is going to be a minus 3x squared. Okay, let's look for like terms. We have a negative 5x cubed and a plus 7x cubed. Those are like terms. What's negative 5 plus 7? Negative 5 plus 7. 2. Right? We're starting at negative 5, we're adding 7. So that is going to give us 2x cubed. And now we have a plus x squared and a minus 3x squared. So if it's just an x squared, that's actually 1x squared, right? What's 1 minus 3? Negative 2x squared. Okay, E. Guys, this is a God math question because we have multiple operations happening here. We first need to times those 2, and then we need to sort out that bracket before we subtract. Okay, if we can subtract after that. So what am I going to get if I say 2x times 3x? 6x squared. Minus, now we again must square everything in this bracket. So 4 squared is 16. Right? 4 times 4. And then x squared is x squared. Okay, now I can subtract all those like terms, right? Yes. Okay, what is 6 minus 16? Negative 10 x squared. Good question. Is it helping, guys, that we're doing these algebra questions? Okay, I did say that you had to do, which ones were they? Was it A to L from revision 7? I'm not going to mark that now because it's going to take very long and I want you guys to have as much time as possible in class to actually work. So I want you to do the rest of revision 7. Okay, so that is M2. How far does it go? M to Q. Q or no? M to D. See, where is my So guys, something that we have not revised at all is geometry, hey? Remember that this was another thing. You're gonna have to revise that on your own. Yeah, so this is revision 7, guys. You've gone up until L. You were supposed to. So now you're gonna do M to D. All right. What I'm gonna do is tomorrow, before we do the relay, I'll just quickly ask if there were any questions here that you wanted me to go through, and I'll just post the solutions of the rest of it. Okay, so we're not gonna go off the whole exercise, because that will take very long. So what they want you is just to say, what is do you want them to do? That's fine, that's fine. This is eight, what do you think that's? Then I want to try. So this one you have to agree, and we'll also.